This is note-taking guide 2.2, the remainder and factor theorem. This first problem asks us to find the quotient and the remainder by dividing by x minus 5. So what we're going to do here is we're just going to do synthetic division first by putting that 5 up in the corner because we always do the opposite. And then grabbing our coefficients over here. We check for all of our powers. We have 3, 2, 1, and none. So we're going to just put our numbers up into the top of our box. We'll have 2, negative 13, negative 7, and 4. To do synthetic division, we drop the first number straight down and multiply from the corner. So 5 times 2 is 10. This adds to negative 3, multiplies to negative 15, adds to negative 22. That multiplies to a negative 110 and adds straight down to negative 106. So our remainder right here is a negative 106. Then they ask us to evaluate f of 5. So what we're going to do is we're going to substitute 5 in up here again every time we see an x. So we're going to do 2 times 5 cubed minus 13 times 5 squared minus 7 times 5 plus 4. 5 cubed is 125. 125 times 2 is 250. So the first number came from there. 5 squared is 25. 25 times 13 is 325. It's negative because of the sign out in front. Negative 7 times 5 is a negative 35, and then we have plus 4. When we take our calculator and we add those all together, guess what we get? We get a negative 106, which is exactly the same as the remainder we got above. This remainder theorem that we're studying today actually says if you're going to divide by x minus a, you could actually just find f of a, and it will give you the remainder that you would get if you divided by the x minus a. So if you're doing a problem like this next one right here, where I asked you to find the remainder, then we can totally just substitute in our number instead. So because this is x minus 1 over here, the number I'm going to substitute in is f of 1. So I'm going to do 1 cubed minus 3 times 1 squared plus 8 times 1 minus 4, and just simplify that. 1 cubed is 1. 1 squared is 1 times negative 3 is still negative 3. 8 times 1 is still 8. And minus 4. Add those together. These two together would be a negative 2. Negative 2 plus 8 would be 6. And 6 minus 4 would be 2. If I were to take the time to do synthetic division, I would put a 1 up here in the corner and then use my coefficients of 1, negative 3, 8, and negative 4. When I did that, my remainder would be 2. I think I'll just do that real fast just to show you that it does work. Drop the 1 down, multiply to get 1, add straight down to get negative 2, multiply to get negative 2, add to get 6, multiply to get 6, add straight down to get 2. So see how my remainder is the same as what I got when I substituted in f of 1. This seems like a good time to just remind you that when we talk about the zero of a function, the root of a function, or the solution of the function, we're talking about the exact same thing. So maybe if our solution was like it was just a minute ago, x equals 2, then our solution would be written x equals 2. But the minute we say factor instead of a solution, it's written in x minus c form. For instance, you know that x minus 2 or x equals 2 came from x minus 2 inside parentheses set equal to 0. So in factored form it looks like this. In solution, root, or 0 form it looks like that. Alright, this next problem asks us when f of x equals 2x cubed plus kx squared plus 4x minus 15. If it's divided by x minus 2 and the remainder is 45, then what is k? So here's what we're going to do. We're going to just substitute in a positive 2 here. So we're going to have 2 times negative 2 cubed plus k times negative 2 squared plus 4 times negative 2 minus 15. And we're going to worry about the remainder part in just a minute, because we know if we substitute our numbers in right here, that's going to get us our remainder, and we know that our remainder is going to be equal to 15. So let's just find what this is and set it equal to 15. So negative 2 cubed is a negative 8. Negative 8 times 2 is a negative 16. Negative 2 squared is 4, and 4 times k is 4k. 4 times a negative 2 is a negative 8, and then I have minus 15 back behind. So if I combine these together, I'm going to have 4k, and then I'm just going to do that on my calculator really fast. I have a negative 16 minus 8 minus 15, which is a negative 39. So I have 4k minus 39, and I know it's equal to my remainder. My remainder is 45. So I'm just going to solve that now for k. To isolate the k, I have to get rid of the 39, so add the 39 to the other side. When you do that, you get 4k equals 84. Divide both sides by 4, and you get k equals 21 for your solution. The next example says what's the remainder, and it gives you x minus 4, or I'm sorry, x plus 4, which means when we substitute in, we're going to find f of negative 4. You could totally do synthetic division here if you wanted to find the remainder. It's your choice. Or you can substitute it in. You'd have 3 times negative 4 to the 4th minus 7 times negative 4 cubed plus 2 times negative 4 squared minus 5 times negative 4 plus 9. After you get it substituted in, you might decide you want to do synthetic division. This is quite a lengthy problem. When we do 4 to the 4th power, or negative 4 to the 4th power, we're going to get a positive 256. We're going to times that by 3 and get 768. Then we're going to come and do negative 4 cubed. Negative 4 cubed is a negative 64. Negative 64 times a negative 7 is a positive 448. So I'm going to add 448 here. I'm going to square the 4 here and then times it by 2, which is going to be 32. This will be plus 20 and plus 9. This is just now a calculator problem that we're going to put in. 768 plus 448 plus 32 plus 20 plus 9. I get 1277 when I substitute that in. The next example here is just to remind us that a polynomial f of x has a factor x minus k if the remainder is 0. And that makes sense, because if we divide something by a number, if the remainder is 0, we call it a factor. We know it divides into it evenly without a remainder. So really these next couple of questions are just going to ask us if when we do the division, whether or not we have a remainder of 0. Is it or is it not a factor? So on example 3 here, given the polynomial x to the 4th plus 2x cubed minus 7x squared minus 8x plus 12, is x minus 2 a factor of that? And then it asks you about x minus 4. So if we want to know if x minus 2 is a factor, we could do synthetic division like we learned yesterday, or we can do the factor theorem that we learned today, the factor and remainder theorem, and substitute in negative 2. So I would do negative 2 to the 4th power plus 2 times negative 2 cubed minus 7 times negative 2 squared minus 8 times negative 2 plus 12. And I'm just going to simplify that. So negative 2 to the 4th power is a positive 64. Negative 2 cubed would be negative 8, and negative 8 times 2 would be a negative 16. Negative 2 squared would be positive 4. Positive 4 times a negative 7 would be a negative 28. Negative 8 times negative 2 is a positive 16. And then I'd have plus 12 from the back. So punch that in your calculator and see what happens. 64 minus 16 plus, actually minus 28 plus 16 plus 12. When you punch that in, you get 48. 48 is not 0 for a remainder. So is x plus 2 a factor? The answer would be no. Then it asks us to try x minus 4. In order to do that, we would put 4 into our exact same equation. I'm going to change colors here so that we can see the difference there. I'm going to substitute it in. So I'm going to do, we're substituting in positive 4 this time. So positive 4 to the 4th power plus 2 times 4 cubed, my 7 times 4 squared, minus 8 times 4 plus 12. 4 to the 4th power is 256. 4 to the 3rd power is 64. 64 times 2 is 128, so plus 128. 4 squared is 16. 16 times a negative 7 is negative 112. Minus 32, because 8 times 4 is 32, plus 12. So we're going to punch that in our calculator and see what happens. 256 plus 128 minus 112 minus 32 plus 12. And I got 252 this time. So is this one a factor? The answer would be no. Alright, I was just looking at my work to double check these to see if I did them right. And I'm concerned up here at the top that I didn't catch myself when I was doing 2 to the 4th power. 2 to the 4th power is not 64. Sorry about that. 2 to the 4th power is actually 16. So if I take a minute and do the math again on that, the math actually tells me when I do this part right, which I didn't mean to erase that, sorry about that. When I do this right, it actually has a remainder of 0, which is the correct one. So is this one a factor? The answer would be yes. Again, I made an error right here. When I raised 2 to the 4th power, it should have been 16. And the reason I know that I did that wrong is what I did was I paused the video really fast and I did synthetic division on both of those. And when I did synthetic division on this one, I got positive 252, so I knew I was right. But when I did synthetic division on this one, I got 0, which told me somewhere in this part right here I made an error. So I went back and checked, and I did make an error at 2 to the 4th power. So guys, be careful. Even I make mistakes, and I apologize about that. But it's good to see that you can go back and find your error by checking with synthetic division. Thanks for watching this note-taking guide.